Hello, Algebra 2 students. My name is Ms. Davis, and I will be one of the 3 voices you'll be hearing this year. This video will cover Unit 9, Skill 2, Writing Equations from Graphs. So please pause the video and take a moment to write down our essential question. How can we write a trig equation from a graph using our cab values? So take a moment and write that down. And here we go. So writing an equation of a function that's already graphed. We're going to be using and finding these cab values. They're going to be 3 numbers that we can get from the graph. And before we do that, I just want to take a note on the side to remind ourselves of the general trig equations for both sine and cosine. So if we have a sine function, we're going to be writing our equation as y equals a times sine of b times x plus the c value. And I'm just going to really quickly sketch a positive and negative sine curve just as a reminder. So if we have our little graph here, a positive sine curve would start at the midline, go up first, down, and then back to the midline. So that would be a positive sine graph, whereas a negative sine curve would start at the midline and go down first, up, and then back to the midline. And that would be a negative sign. We're going to need to know and recognize that in order to determine if the a value at the beginning of our equation is positive or negative, depending on if it goes up or down first. Then for cosine, our general equation is y equals a times cosine of b times x plus c. So when we have a positive cosine graph, let's sketch that out. We're going to start high and end high, and in between dips down and makes like that U shape. So that's a positive cosine. And our negative cosine graph starts low and ends low. So we're going to start low below the midline, jump up, and then end down there. That would be our negative cosine. Okay, so just a little refresher on what those are going to look like. So let's talk through some of these values. So the very first thing you're always going to want to do is find the C value. Oops. The C value is the midline, the shift line, and it should be exactly between the max and the min. If you need to, count the blocks and divide by 2 if you have to find the middle. So that will be your C of your cab values. After you find the midline, then you're going to find the A value. And so once you have your midline drawn, you're going to determine the amplitude. So your amplitude is that height from the midline to the max or min. So your amplitude is going to be the A value. And always remember to pay attention to the scale. Sometimes the scale on the left goes up by 1, sometimes 2s, 5s, but that will affect your amplitude. And then after you do that, you want to determine if it's a positive or negative cosine or sine curve. So that's what we just took notes on the side to determine if it's a positive or a negative sine amplitude. So look at the y-axis to find the starting point of the graph. If it's on the shift line or the midline, it's a sine function. If it goes upwards, it's positive. If it goes downwards, it's negative. If it's above the shift line, then it's a positive cosine, and if it starts below the shift line, it's a negative cosine, okay? Then the last of the 3 numbers you're going to be finding is the B value. So the B value is the frequency, and what you need to do is look at the graph and determine how many cycles fit in 360 degrees. So if you can see 360 degrees in your graph, then you're just going to look between 0 and 360, how many full cycles does the graph portray? That would be your frequency value. Frequency just means how many. Or if you can't see from 0 to 360, you're going to find the start and the finish of one complete cycle, and then determine the size of the cycle in degrees. So your B value or your frequency is going to be equal to 360 divided by the period, or how long it takes for one full cycle, if it's in degrees, or your B value, if they want it in radians, will just be 2 pi over the period. Okay? All right, and then after that, after you have your 3 values, you're going to plug in and write the equations. Okay? So here we go. Let's go ahead and try an example. So example number 1, we're going to look at the graph and we're going to determine first our midline. So you want to find the exact middle of this graph, and if I'm looking at it, I can see that the exact middle is right there down the center of that sine function. So how do we know it's a sine function? Look at the starting point. So the starting point's right there. It starts on the midline. So this is the midline here. And if it starts right on the midline and ends on the midline, see how this is one complete positive sine curve. So it's one complete positive sine curve there. So we're going to go ahead and write out what we need for our equation. So we need a C value, an A value, and a B, where C is the midline. So our midline is actually equal to x equals 0. So our C value for this one is 0. Our amplitude is going to be our distance from the max or the min to the midline. So how far away are those? They are exactly 2. So you can just count the blocks for this one. So the amplitude is 2. And then B is our frequency. So how many full cycles fit within 360 degrees? So we can actually see 360 degrees from this graph. So how many times does a sine curve create full cycles? So if I did one in green there, I'm going to do the second one in red. There's another cycle, and then our third cycle. So there's actually 3 full cycles in this 360 degree measure. So our B value is 3 because there's 3 full cycles in 360. Let's say we couldn't see all the way up to 360 degrees. We could also find this number by taking 360 degrees and dividing it by, well, it took 120 degrees for one full cycle, or for one full cycle, so that's the period. So we're going to take 360 degrees and divide it by its period, and that would also give us 3. Okay, so now our last step is to go ahead and write our function. So this is a positive sine graph because it starts at the midline and goes up first. So it's y equals, we're going to do our general form first, a times sine bx plus c. And then just plug in your 3 numbers. So y equals, our amplitude is 2, and it's a positive sine, so it's a positive 2 sine. B is 3, x plus our c value is 0. We don't have to write plus 0 there, but if you wanted to, you could. Or you can also write it, instead of y equals, we could also write it as, I'm going to write it down here, f of x equals 2 sine 3x, and not even write that plus 0. That's probably how you would see it more often. Okay, so let's go ahead and flip to the next page. Okay, so for example 2, we want to go ahead and write out our 3 values that we need. We need C, which is our midline, A is our amplitude or our height, and B, which is our frequency. So looking at our graph, we want to find that midline. So if you were able to just look at this graph and see that the midline is exactly at -2 right there, because it's halfway between the max and the min, then that's great. If you aren't able to do that, look at the max and the min. You could also take the minimum, so -6, and add the maximum, which is +2, and divide it by 2. So that would give us -4 on top, divided by 2 gives us a -2 for the midline. So here's our midline is our C value. Okay, so now next is our amplitude or our height. So we want to look at the distance from our midline to the max or the midline to the min. And see, we have 2 boxes there, but our amplitude is not 2 because the scale is 2 per box. So watch the scale there. So our amplitude is not 2, it's actually 4 in each direction. So our amplitude is 4. And then our B value is our frequency. So in 360 degrees, we actually have that here. We can see 360 degrees from here all the way to there is 360. So we can now go ahead and look. Actually, let's determine if it's a cosine or sine curve. So when we look at the graph, we want to look at the starting point. It starts not on the midline, it starts below the midline. and ends below. So this is a negative cosine. If it starts low and it ends low, oops, it's a negative cosine. Okay, so we know it's a negative cosine graph, and now we want to count, if we can see in 360 degrees, the number of full cycles. So one cycle would be from here up, down, and ends there. There's one full cycle, and then I'm going to do the second one in yellow. So the frequency means that there are 2 full cycles in 360 degrees. Again, if you couldn't see that, in the picture here, 360, we could do 360 divided by how long it takes for one full cycle. So 360 divided by one full cycle takes 180 degrees for one full cycle. So when we divide there, we also get 2. So that should match up there. Okay, now our last step, we got our 3 values. We're going to write this as a negative cosine. So we're going to write y equals, our a values comes first, so it's 4, but since it's a negative cosine, we want to make sure it's a negative 4. Cosine bx, so times 2x plus our midline, which is negative 2. You can write it as plus negative 2, but usually you're going to see minus 2 there. So I'm going to rewrite this as y equals negative 4 cosine 2x minus 2. Final answer. Okay, example 3. Let's go ahead and find our midline. So we know we need the midline, the amplitude, and your frequency. So our midline looks like it's at about, or at exactly, my bad, negative 2. Again, that's a horrible line. Let's make a better line there. Okay, so there's our midline. Cuts it right in half there, so our midline is down at negative 2.
I'm only moving this.
Now the amplitude for this one, each box here is worth 0.25, so our amplitude here is only half, so 0.5 or 1/2. And then in this particular graph, you cannot see 360 degrees. So what we want to do is take a look at one full cycle. So I'm going to look at the starting point here is above the midline. It starts above the midline and ends above the midline, so that makes it a positive cosine curve. And we've got one full cycle from here to here, which is 120 degrees. So to find your b value when 360 degrees cannot be seen, take your 360 degrees, divide by 120 for one period or one cycle, and that divides out to be 3. So there would be 3 full cycles if there was 360 degrees shown on the graph. So we've got our 3 values, and now we can plug into our positive cosine equation. So y equals our amplitude first, so 1/2, positive 1/2, cosine 3x minus 2. Okay, example 4. Start off with our unknown CAB values. Okay, so to find the midline, this one might be a little bit harder to see. So what I'm going to have you do is take your maximum point and your minimum point, add them and divide by 2. So positive 5 plus negative 1 divided by 2 gives us 5 plus negative 1, 4 divided by 2 is 2. So our midline is at 2. Our amplitude is going to be the distance from our midline up to the max. So we've got 1, 2, 3. Going both ways, our amplitude is 3. And what kind of graph would this be? Well, let's see. It starts on the y-axis above the midline, dips down below, and then eventually is going to curve back up over here if it kept going. So it's a positive cosine because it started above the midline. So now our last b value is the frequency. So we cannot see, or actually we can see 360 degrees. It's only from here to here. So we cannot see the whole cycle. So if we think about a positive cosine graph. I'm going to sketch this off to the side. Positive cosine graph would start up high, dip low, and end high. So right now we can see that we have the max up here at 5, and this is the minimum. So we have got 720 degrees at the minimum point down here. So 720 degrees, this is the halfway point here. So this would be one full cycle if we graphed it all the way out. So we're only seeing half of the cycle on this graph. So how many degrees would it need to do one full cycle? Well, if we did 720 times 2 would give us 1,440 degrees for one full cycle. So to find your B value, we take the 360 degrees and divide by the 1,440 degrees for the full cycle. And when we divide that out in our calculator, or divide it out, we get 1/4 or 0.25. So we're actually only seeing in 360 degrees 1/4 of the graph. It's only from here to here, which is from here to here, which is 1/4 of that whole cosine curve. Okay, so now our final step is to write the equation of the graph. So y equals, it's a positive cosine and it's a positive 3 is the amplitude, so 3 cosine, our B value, 1/4 times x plus our midline 2. Okay, go ahead and flip on over. Okay, so a quick refresher that a radian measure is just another unit of measurement, and we can translate that 180 degrees when we're thinking about the unit circle is equal to pi, and 360 degrees is the same thing as 2 pi. Just like we can convert between inches and feet, radians and degrees are interchangeable. So for example number 5, we're going to write the equation just like we did earlier, but now we're looking at graphs where they are in radian measure. So looking at this graph, I just want you to notice that right here at pi, that's 180 degrees. And when you see 2 pi, that's 360 degrees. So off to the side, let's make known our cab values or what we're finding. Our midline for this one is nice and easy, right at 0. Our amplitude, there's no scale there, so we're going to assume that that's a 1 and a -1. So our amplitude, going both ways here, is positive 1. And let's see what kind of graph this is. So where it starts is at 0. So right on the midline, it goes up, dips down, and ends on pi on the midline. So that's a positive sine curve. And we need to determine our frequency. So our frequency, remember, is the number of full cycles in 2 pi or 360. So looking at this graph, if you can tell just by looking at it, there's one full cycle there and a second full cycle there. So our frequency is 2. So B is equal to 2. And if you couldn't see that, what we would do here is we would take, instead of 360 divided by the period, we would do 2 pi divided by how long it took for one cycle. So 2 pi, one full cycle, that green cycle took pi radians. So we're going to do 2 pi divided by pi. Those cancel out, giving us back our 2 for our frequency. Okay, so now we're going to go ahead and write our equation. It's a positive sine curve, so y equals amplitude of 1. You don't really have to write the 1 in there, but I'm just going to do it for the sake of it being new. So 1 times sine bx, so 2x, plus our shift line, 0. Okay, again, you don't need to write that 0 in there, but I just did for the sake of plugging it in. Okay, example B, go ahead and set up what you need. Okay, our midline looks like it's at 3, right in the center there. So our midline, our shift line is at 3. Amplitude here is 2. So our function has a height of 2. What kind of function is this? Sine or cosine? So we're going to look at the starting point is right on the midline. It dips down first and then goes up. So if it's dipping down and then going up and ending back on the midline, it is a negative sine function. So our last value that we need is our period, so b. So if we need to find our period, or how long it takes to make one full cycle of this sine curve, our period is equal to 3 pi. Because it takes 3 pi to make it from the beginning to the end of the cycle. So our b value, instead of doing 360 again on top, we're going to do 2 pi divided by the period, which is 3 pi, and reduce, or cancel out our pi's. So our period is, our frequency, sorry, is 2/3. So plugging back in, we've got a negative sine function. So when we write this, we want to make sure we have a negative in front of the amplitude. So negative 2 sine 2/3 x plus your shift line of 3. Okay, next one. Go ahead and draw in your shift line. Is right at positive 15. So our C value is positive 15. Our amplitude, now make sure you watch the scale here. These are going up by 5s. So our amplitude is actually 5, not 1. And our period, sorry, our frequency is going to be, looks like we can't see the denominators here. I'm just going to make note that these are all over 2. So these are all over 2. Okay. So in order to determine our frequency here, we want to do 2 pi divided by the period. So again, the period is how long it takes for one full cycle. So if we're looking at this graph, I'm going to start and go backwards, because if you go to the right of the starting point, you can't see a full cycle. So I'm going to go this way to the left. So one full cycle is right there in green. So if it starts above the midline and ends above the midline, we've got a positive cosine. And one full cycle goes from here at 0 over to 5 pi over 2. So our period is equal to negative 5 pi over 2. So when I plug that in over here, I get 2 pi divided by negative 5 pi over 2. Now we're going to use an old method that you guys haven't seen in a while probably, but it's keep, change, flip when you divide with fractions. So when I go ahead and rewrite this guy down here, I'm going to have 2 pi, keep that the same, times its reciprocal. So we're going to flip that fraction around to 2 over 5 pi negative. And that 2 pi there we can put over 1 if we'd like. So we can actually cancel out the pi's here if there's one on the top, one on the bottom. And we're going to multiply across. So 2 times 2 gives us a 4 on the top and a 5 on the bottom. Okay, so we can actually ignore this negative because we are talking about distance, or how long that period is. So it's just a positive 4/5. So when we write our equation out, we've got y equals, again, it's a positive cosine, so it's a positive 5 cosine of our b value, 4/5 x, plus our midline of 15. Okay, one more example. All right, our last two examples here are some word problems. So let's read through example 1, or the first example here. The Sea Dragon, not one of my favorite rides at Seabreeze. It used to make me pretty sick. But it's a pendulum ride at an amusement park, moves from its central position at rest according to a trigonometric function. So they give you this equation, and we got to kind of envision what the Sea Dragon does. It makes this back and forth motion. Right, it goes up, then it goes down. It goes up, and then it goes down, back and forth. So that motion can be represented by this function in this equation given right here. So where t represents time in seconds and h is the height above the ground. So, question asked, what is the position of the pendulum? So what is the height? At 15 seconds to the nearest tenth. So they're asking you what the height is after a certain amount of seconds. And t represents time in seconds, so they're asking you basically to plug in t equals 15. So we're going to find h of 15. So after 15 seconds, what's the height? We're going to copy down the equation and just substitute in cosine of pi over 3 times 15 plus 12. And you're going to type this whole thing right into your calculator. But actually what we want to do is we want to remember that pi is equal to 180 degrees. So if your calculator is in degree mode, you want to use 180 degrees here for pi. If it's in radian mode, you want to use pi. So let's rewrite this in degree mode, just so you can see the difference. 180 over 3 is the same value as long as you're in the right mode. Okay, and this is all in calc, in your calculator, so when you type it in, you end up with 22. Okay, so it says the next question is, what is the highest the pendulum swings? So basically what they're asking you, if they're asking you for the highest, is what's the max value? So if we look at our equation, our shift, let's see what we can identify from our equation. This right here, that number in the front is the amplitude. So that means the amplitude is equal to 10, and your shift line is 12. So if you think about, off to the side, I'm going to kind of sketch this. Your midline is at 12, and your amplitude is 10. So that means that if it's a cosine graph, it's going to start all the way up at 12 plus 10 is 22, way up here, and then it's going to swing down and go back up. So the max for this particular question can be found by adding the midline plus the amplitude to get up to the max. And our midline was 12 plus our amplitude is 10 is 22. And now our very last example, the temperature in an office is controlled by an electronic thermostat. The temperatures vary according to the sinusoidal function, y equals blah, where y is the temperature, C in Celsius, and x is the time in hours past midnight. So what is the temperature in the office at 9 a.m. when the employees come to work? So if the time is, x is time past midnight, then 9 a.m. is 9 hours past midnight. So that means that our x value they want us to plug in here is 9, so 9 hours past midnight. So that just means plug in. So we're going to do y equals 19 plus 6 sine. Now again, I want you to use 180 for pi of 180 over 12. Parentheses x minus 11, so 9 minus 11. Close parentheses. And then when you type this all in your calculator, you'll end up with y equals 16 degrees Celsius. Okay. And then last but not least, what are the maximum and minimum temperatures in the office? So our maximum is going to be equal to your shift line or your midline plus the amplitude. And your minimum is equal to your midline minus your amplitude. Because if you think about that sine function, for here, it's a sine function, your midline plus the amplitude gives you the max, and your midline minus the amplitude gives you the min. So let's go ahead and plug in these values. So our maximum, well, let's see, our equation says that our midline is, or the shift line, that midline there is the number that's added onto the whole function. So 19 is our mid, plus the amplitude is the number in front of the sine, plus 6 is equal to 25. And then our minimum is again our midline, so 19, minus the same number, minus our amplitude. So that gives us 13. So there's your max and there's your min. Okay guys, you're not going to get good at this unless you do the practice. Have fun.